Hi guys, this is the Logic Tutor. You're welcome back to this channel, and if you're new here, click on the subscribe button. Endeavor to turn on the notification bell to let you know when we drop our video, and try to also share our content if you like what you see. So we want to discuss a concept here, and this is applicable for the O-level student, or if you're still in senior secondary school offering further maths. And that is probability distribution. So I want to talk about probability distribution. Probability distribution, as the case might be. So what do we understand by probability distribution? So this is talking about some event, and then the event might take place, we're talking about a random event here. So and the distribution of the probability of some event. Okay, let me make my explanation with this. So now the probability, just like the theory of probability we learn right from the basic class, we understand that probability is a game of chance, and it is equals to the number of required outcome over number of possible outcomes. So which means probability PR is what? Number of required outcome all over number of possible outcome. Number of possible outcome. So when an event occur, so we have a certain number of possible outcome you might get, and then the required outcome is what you intend to have. For instance, when you toss a coin, so the number of possible outcome is either head or tail. When you toss just a single coin one time, so the number of possible outcome is what? Head or tail, which is 2. Now, the number of required outcome is if I want head to show up. So that is the probability of having head is just 1 all over the total number of possible outcome, which is 2. So that is probability. Now, when we now talk about probability distribution, we are talking about maybe when events take place in number of times, and then we want to consider the required outcome distributed over the number of times the event took place. Now, probability distribution, we have two types of it. We have the discrete and we have the continuous. So okay, let's get rid of this and talk about that now. So when we talk about probability distribution, we have the discrete rather, discrete distribution, discrete probability distribution. I'll put that as P, the probability distribution. Then we have the continuous probability distribution. So continuous probability distribution. So we're going to pick the discrete in this video, the discrete in this video. So what do we understand by discrete probability distribution? So these have to do with events that are not continuous, let's say that are discontinuous. So we have two types of it. We have, or let's say 3 types. We have the Bernoulli's distribution, Bernoulli distribution. Then we have the binomial distribution, binomial distribution. we have the Poisson distribution. Poisson distribution. So these are the three types of discrete binomial, probability distribution. So we're going to pick it one after the other and explain them. So now we're going to start with Bernoulli's distribution, or let's take binomial distribution first. So talking about binomial distribution, we have some events that can take place. For instance, tossing a fair coin. Let's use that as a typical example to explain the binomial distribution. Now, the possible outcome is just head or tail. So which means we have two possible outcome, which is head or tail. So suppose we want to get head, that is our choice to get head. So which means getting head is going to be success. So and getting tail is going to be what? Failure. So the two possible outcome is either success or failure. So now we have this binomial distribution when you make different trials. For instance, when you toss a fair coin one time, you are not going to apply binomial distribution. But when you toss it 2, 3, or more than 4 times, so that is the number of trials. So for the first trial, you toss the coin for the first time, that is your first trial. So you might have head or not. So we just have either successful or failure. Now the probability of having head, that's P success. Let me put that as P success. That's the probability of having head. Don't forget, the probability that something will happen is just 1. So let this P success be, for the case of the die, of the coin rather, it's going to be 1 over 2. 1 over 2, because you have two possible outcomes, which is either head or tail. That is success or failure. So it's 1 over 2. Now the probability of failure must also be the same thing as probability of success, because probability of failure is 1 minus the probability of success. So we are gonna make probability of failure to be Q, or any letter of your choice. Then probability of success to be P. So which means probability of failure Q is 1 minus probability of success. Now don't forget, in tossing a coin, the two possible outcome is head or tail. So we have two possible outcome. So the probability of getting head, if we choose to have head, that's success. So probability of success is going to be 1 over 2, just like I described here. 1 over 2. And the probability of failure as well, in that case, is still going to be 1 over 2. In the case of the coin, it's still 1 over 2. Now that is for the first trial. Imagine we try one more time, another time again, another time, up to a particular number of trial n. So the number of trial now is n. So if n is number of trial, so binomial distribution is just talking about how is success distributed across the number of trials. Okay, in a nutshell, let me just explain this way, that if we toss a coin for 5 times, the individual trial does not depend on another. So the first trial, I might get head or tail. Second trial, I might get head or tail. third trial I might get head or tail until the number of trials accumulate. So if it is 5 trials, we know that we have n equals 5. Now, the probability of getting head in each trial, since it is a coin, it will only be 1 over 2. And the probability of getting tail is also 1 over 2. Now, how is the probability of success distributed across the 5 trials? Or how is the probability of failure distributed across the 5 trials? This is what we mean by binomial distribution. So now, if we want success 3 times, now how can the 3 times of success be distributed across the 5 trial? So, it could be the first one will be successful, the second will not, the third will be, the fourth will not, the fifth will be, or the other way around. So the probability of success will be distributed across the 5 trials. So which means that, how do we get the probability distribution of success across 5 trials? So since the number of trials is more than 1, we call it binomial distribution, because the event is likely going to have 2 results. So that's the property of binomial distribution. The first property you should know is that the event will have 2 possible outcomes. Just like an example with uh, tossing of a coin, it's going to have just 2 possible outcomes. So you're going to choose between success or failure. So now, if you choose to have head, that means your head is going to be success. Not having head is going to be failure. So that is it. So the probability, the P, is probability of having success in every trial. Let's put it that way. P is the probability of having head in every trial. And in every trial, the probability of having success is just 1 over 2. Then the probability of having failure in every trial is also 1 over 2. Now, if we want success 3 times out of 5 trials, what would be the distribution of these 3 success across the 5 number of trials? That is what binomial distribution is all about. So now, let us take it this way. To find the binomial distribution, we use the formula P into X equals R. Okay, you'll be wondering what R means, okay? So P into X equals to R, or whatever, equals to N combination R, P raised to power R, multiplied by Q, all done. So you have N combination R, P raised to power R, with Q raised to power N minus R. Okay, let me rewrite this. That is N minus R. So this is the formula for binomial distribution. Now, don't forget I made mention that if you're looking for success 3 times, if that is what you want the success 3 times. Wanting success 3 times means that you want head to show 3 times. Using the scenario of coin, a fair coin as example. So which means R is going to be 3. And if you're trying this for 5 times, if you're choosing the coin for 5 times, the number of trials is going to be N, which is 5. Then don't forget, P is the probability of having head in every trial. Q is the probability of having tail in every trial. So this formula directly represents the binomial distribution. Okay, let's take a question to explain that. Take for instance, we're told that a fair coin is tossed 5 times. So if we say a fair coin is tossed 5 times, so which means the number of trial is gonna be 5, and it's gonna be 5. That's the number of trials. So which means in every trial we have two possible outcomes. So the probability of success is gonna be 1 over 2, and the probability of failure is also going to be 1 over 2. So now the question says that a fair coin is tossed 5 times. Continuation: what is the probability of getting success 3 times? So the probability of getting success 3 times is distributed across these 5 trials. So which means we're just going to follow the formula P. So we said success 3 times, so we are meant to write the parameter. So R is going to be 3 in this case. So in order to continue with our work, we want to find the probability of having success 3 times. So that's probability of x equals to 3 equals to, that means you're gonna have 5. Don't forget the formula up here. The formula says that you have n combination r, the probability of success raised to power r, multiplied by probability of failure raised to power number of trial minus r. So we go again here now. So we're gonna have a 5 combination 3, 5 combination 3. You can actually press this from your calculator. 5 combination 3. So when you have 5 combination 3, then the next is you would have to get the probability of success, which is definitely 1 over 2. So we have 1 over 2 raised to power 3. Then you now have probability of failure, which is 1 minus probability of success, which is still half, then raised to power 5 minus 3. So in this case, what we're going to have is this equals to 5 combination 3, then this will be 1 over 8, then multiplied by, this is going to be 1 over 4, because 5 minus 3 is 2, and if you have 1 over 2 raised to power 2, it's going to give you 1 over 4. So then the next is to evaluate your 5 combination 3 multiplied by 1 over 8 multiplied by 1 over 4. You would get the probability distribution. 5 combination 3 is going to give us 10. So we'll be having 10 multiplied by 1 over 8 times 1 over 4. So if you do this maths well, to get a decimal, so the probability distribution of x equals 3 is going to be 0.312, or let's say 0.313. So this is the probability distribution. This is a typical example of it. So we have more and more example. Now there is a special case of this, and that is when you're talking about Bernoulli's distribution. Bernoulli's distribution is just like binomial distribution, but in Bernoulli's distribution you would only have one trial. So when you have one trial, you could only have a single expression, like a single expectation. So you're talking about the probability distribution across a single trial. So that is just what Bernoulli's distribution is all about. So then, to call it short, we're going to pick Poisson distribution in our next video. So you can try so many questions on this, as maybe some of the questions will be posted in the next video based on binomial distribution. So then you can just go through them. This is just to explain binomial distribution and Bernoulli's distribution because they are similar. So in case you might be mixing the both together, binomial distribution occurs when your trial is more than one. Then Bernoulli's distribution is when you have a single trial. Thanks for watching. Please subscribe to the channel. It's free. Thank you.